Okay, it's a confusing question, there's no doubt about it. But they tell me what this big f of x is, but they say apply integration to the known result. And we just did this. All right, so I want to go through the integration, and certainly you might say I can't remember, but I want to point out if you were given the natural log of x dx, you should be able to show that this is x ln x minus x. You should be able to show that. All right, so what I want to do is kind of do that here, but I'm going to write this maybe a little differently. I'm going to write integration ln 1 plus x dx. I'm going to let 1 plus x equal u, just temporarily, by the way. We'll come back to x later. So that means du is equal to dx. Now what is this going to give me? It's going to be, I'll put a star over here, natural log of u du. What's that going to give me? Well, again, this is pretty easy to show. It's going to be u ln u minus u plus some constant of integration. Should probably put that over here too. All right, so I'm going to go back to land of x's, by the way, and let's put this down. It's going to be, let's see, 1 plus x times the natural log of 1 plus x minus, what's u? 1 plus x plus some constant of integration. Maybe I should put a little star over here too. All right, so let's just do that. We just went through a bunch of work, and I figured this side out. Not that bad. I'll write that down for you. So if I integrate the left-hand side, you get 1 plus x times the natural log of 1 plus x minus 1 plus x plus some constant of integration. What does it equal? Well, I'm going to integrate this side over here, which really doesn't look that bad. What's it going to be? X squared over 2. That's the first term. Then you're going to get minus x cubed over 3 times 2. Then you're going to get minus x4. And that's going to be, let me see if I made a mistake over here. So x squared over 2, x cubed, 3 times 2, x4, 3 times 4. Maybe we'll put down 4 times 3. And then that's a plus sign, sorry about that. Minus x5, and it's going to be 5 times 4. I think I got the pattern. All right, now someone says, what are you going to do here? I have to pick an x that's easy to evaluate and to get the c, by the way. So the x I'm going to pick x to be 0. And the main reason for that is this side's really easy to evaluate at 0. And what's that going to give you? That's going to give you 0. All right, so the right side's 0. Now what do you get on the left side? You're going to get 1 times the natural log of 1. Then you're going to get minus 1 plus c. All right, so let's see if we can do that. The natural log of 1 is 0, so c would have to be 1. All right, c must be 1. Let's write that down. And I want to get my eraser out to do that. And I think I'm going to start to make some erasures now. Kind of done with this business over here. And exams don't erase things that you're working on. I mean, don't do that. You can cross them out. The reason I'm erasing this stuff over here is I'm pretty satisfied after talking through it that we got there. Just like it was at the blackboard, I'd probably say, you know what, we're done discussing that. Any questions, let's move on. But I got this relationship over here. Someone says, I don't even remember why you did that. I did it because I want to get a different series. But before I do that, I want to just simplify a tiny little bit. So I'm going to write it as, let's see, 1 plus x, natural log of 1 plus x. And then what do you get? You get minus 1 minus x plus 1, which would just be minus x. And what does that equal? Well, I'm kind of looking at it, and it's a summation problem. And I know it's alternating. I'm going to put down, minus 1 to some power. I know there's an x involved there. And the x is like 2, 3, 4, so forth and so on. So let's think about it. I'm seeing the bottom. Let me write this down. It's 2 times 1 here, really. And 3 times 2, 4 times 3. So I'm going to say, let's start n at 1. Going off to infinity. So I'm going to say, it looks like if I start at 1, it's going to be n, and then what's in front of it, something bigger than n, so it's n plus 1. And what's the power there? Looks like n plus 1. And what's the power over here? N plus 1. And why is that? I want the first term to be positive. All right, so I got that series there. All right, let me just get my erase route. Erase this business over here. I'm done with that. And I'm getting closer to it, but not exactly. What I'm going to do is, I guess I could have wrote this down as u. Maybe I should do that now. So wherever we see an x, I'm going to put a u in down instead. Okay? Just put a u there. What I'm going to do now, whoops, I forgot the u here. I'm going to let u equal to 5x. Let's see what happens. What do you get? Well, it's going to be 1 plus 5x ln 1 plus 5x minus 5x equals a sum n equals 1 to infinity minus 1 to the n plus 1 5x to the n plus 1 over n plus 1 times n. All right? And certainly we've discussed this interval before, and the u over here has got to be between minus 1 and 1. And let's take a look at it. If I put 5x down, what would the x have to be between minus 1/5 and 1/5? All right? Now, of course, we're not testing endpoints at the interval at this point, but I want to look at the answer key and see how we did. All right? So it's over here somewhere, hopefully. Yeah, so I want to point out they did something with it, and I want to go through that with you. I'll write that down for you. Oops, that doesn't look right. They took the 5 out. They're multiplication symbols, by the way. Let's take a look at it, see how we did. And I'm seeing that, their finality over here. We already put down the interval, by the way. So, minus 1, it's starting at 1 to infinity, minus 1 to the n plus 1, we got that. 5 to the n plus 1, we got that. X to the n plus 1, we got that. And n plus 1, we got that. Thank you.